Hi children, we continue with our second chapter, acids, bases and salts, and today's topic is water of crystallization, and this is the last topic of the second chapter. So let's move on to that. Water of crystallization. In the first chapter and also in the second chapter, in the previous classes, we have learned a few substances like Fe2O3 dot XH2O, Na2CO3 dot 10H2O. When I wrote these compounds, I told you about water of crystallization. Within the formula of the compound, there are water molecules trapped, and I told you these molecules are known as water of crystallization, and we will be learning it in the second chapter. So now it's time to learn about water of crystallization. So within the crystal structure of the molecule, there are water molecules trapped. We call it as water of crystallization. Here it is 10 molecules of water, but in rest the number of water molecules is not fixed, so we write it as X. So this is the number of water molecules present in one formula unit. One formula unit of rest is Fe2O3. One formula unit of washing soda is Na2CO3. Number of water molecules present in one formula unit of a substance is known as water of crystallization. Okay, let's write the definition now. Write the definition. The number of fixed number of water molecules present in one formula unit of a substance. One formula unit of a substance is known as water of crystallization. Fixed number of water molecules present in one formula unit of a substance is known as water of crystallization. So this is one formula unit of sodium carbonate, Na2CO3. In that we have 10 molecules of water. So that is the water of crystallization. In iron it is not definite, so we write it as X. Now we will see other examples of compounds which contain water of crystallization. The most important one is copper sulfate, CuSO4 dot 5H2O. CuSO4, copper sulfate, blue colored crystal, and it contains 5 molecules of water. We call it as hydrated copper sulfate. Hydrated copper sulfate. It is blue in color, so its common name is blue vitriol. Hydrated copper sulfate, CuSO4 dot 5H2O. So when water molecule is present, water of crystallization is present, we call such molecules as hydrated molecules. Sodium carbonate with water of crystallization, we called it as hydrated sodium carbonate. Washing soda, hydrated sodium carbonate. Rust is hydrated iron oxide. So compounds with water of crystallization are known as hydrated compounds. That's why the name hydrated copper sulfate. It is blue in color, blue colored crystals. Okay. Now what happens to it upon heating? So it is heated. Then what happens is the molecules of water are lost. Blue vitriol loses its water molecules and it changes to copper sulfate without water molecules. CuSO4, without water of crystallization. We call it as anhydrous copper sulfate. So without water of crystallization, this compound is known as anhydrous copper sulfate. It is white in color. Okay, the color also changes. The blue colored crystals changes to white in color. Now, again you add a few drops of water to it. You moisten this anhydrous copper sulfate with a few drops of water. Then again it changes to hydrated copper sulfate, and the blue color is regained. Because it attains the water molecules back, and from white it changes its color to blue. Okay, so that's important. What happens to what is hydrated copper sulfate? CuSO4 dot 5H2O. Its color is blue, so we call it as blue vitriol. Okay, due to the presence of 5 molecules of water, it is blue in color. But upon heating, the 5 water molecules are removed from it and it changes to anhydrous copper sulfate, which is white in color. But when you moisten it with a few drops of water, it regains its water of crystallization and the color appears blue again. It changes to blue again. Now we will see the other examples of compounds with water of crystallization. One example is iron sulfate FeSO4.7H2O. Hydrated iron sulfate. Hydrated iron sulfate, it is commonly known as green vitriol. It is green in color, so it is known as green vitriol. Then washing soda we saw, already we saw Na2CO3.10H2O. Its name is washing soda, hydrated sodium carbonate washing soda. It is colorless, white in color. White in color. Then one more you will learn, that is CaSO4.2H2O. calcium sulfate.2H2O. This is commonly known as gypsum, and this is also colorless, or we say white in color. Okay, so that's about compounds with water of crystallization. So what is water of crystallization? The fixed number of water molecules present in one formula unit of a substance is known as water of crystallization. We learned about those compounds like rust, washing soda, etc. For example, copper sulfate, CuSO4.5H2O. We call it as hydrated copper sulfate. All compounds, all molecules with water of crystallization are known as hydrated compounds. Okay, so copper sulfate crystals are blue in color, so commonly we call them as blue vitriol. Upon heating, these water molecules are lost and the compound becomes anhydrous, CuSO4. Without water of crystallization, it is called anhydrous. Its color is white. But the blue color can be regained by adding a few drops of water. It changes to CuSO4.5H2O. Hydrated again, color is also regained. Okay, other examples are green vitriol, commonly called green vitriol, iron sulfate, FeSO4.7H2O, hydrated iron sulfate. Then as you know, washing soda, it is white in color. Then CaSO4.2H2O, gypsum, it is known as gypsum, it is again white in color. Now in detail we will learn about a compound with water of crystallization, that is plaster of Paris. Formula CaSO4.5H2O. Its name is calcium sulfate hemihydrate. Calcium sulfate hemihydrate, CaSO4.5H2O. Plaster of Paris is an important compound. Learn the formula and the chemical name. CaSO4.5H2O is known as plaster of Paris and the name is calcium sulfate hemihydrate. Now coming to its preparation. It is prepared from gypsum. It is prepared from gypsum, CaSO4.2H2O. It is heated to 373 Kelvin. It is heated to a temperature of 373 Kelvin. That what happens is it loses the water molecules. How many water molecules are lost? CaSO4.5H2O. Already it had two water molecules. But in the product it has only half water molecules. So how many water molecules are lost? 1.5 water molecules are lost, and you get plaster of Paris, calcium sulfate hemihydrate. So this is the preparation of plaster of Paris by heating gypsum to a temperature of 373 Kelvin. Then water molecules are lost and we get plaster of Paris. Now again, when you mix plaster of Paris with water, this is an important reaction. Write chemical equation for the reaction between plaster of Paris and water. It is mixed with 1.5 molecules of water. It changes back to gypsum again, hard solid mass of gypsum. So that's why it is said that plaster of Paris should be kept in moisture proof container. It should be kept away from water. So once it comes in contact with water, it again sets into a hard solid mass of gypsum. Okay, so this is the reaction between plaster of Paris and water. Plaster of Paris reacts with water and changes to hard solid mass of gypsum. Now, what are the uses of plaster of Paris? Plaster. So, the first use is it is used as a plaster for keeping fractured bones, arms, legs, etc. in the right position, as a plaster for protecting fractured bones. So many of you might have had fractures and all. Then the plaster, the hard plaster that is applied over it is plaster of Paris. It is mixed with water. When this plaster of Paris is mixed with water, it sets into a hard mass of gypsum. So it is used as a plaster for protecting fractured bones in the right position. Then it is used for making toys and other decorative items. It is used for making toys and other decorative items like statues and all are made from plaster of Paris. Okay, so that's about plaster of Paris. What is plaster of Paris? Calcium sulfate hemihydrate, CaSO4 half H2O. How is it prepared? It is prepared from gypsum by heating gypsum to a temperature of 373 Kelvin. Then the water molecules are lost and you get plaster of Paris. Now, when plaster of Paris comes in contact with water, it again changes to a hard solid mass of gypsum, CaSO4 2H2O. So, it is said that plaster of Paris should always be kept in moisture proof container. In presence of water, it changes to gypsum. Now, coming to its uses. It is used as a plaster for protecting fractured bones in the right position, and also it is used for making toys and other materials. Other decorative items are prepared from plaster of Paris. Now, one more thing, in the last board exam, there was a question, why this plaster, in the formula of plaster of Paris, there is half molecules of water. Give reason. The answer is that actually the formula of plaster of Paris is CaSO4 H2O. So, two formula units of calcium sulfate share one molecule of water. Actually, we write water of crystallization for one formula unit, but this is the actual formula. Two formula units of calcium sulfate share one molecule of water. So, we have to change it to one formula unit. So, we divide it with 2. So, we get it as CaSO4 half H2O. Okay, so that is the answer. Two formula units of calcium sulfate share one molecule of water. So, when we write it for one formula unit, it changes to half water molecule. So, that is last year's board question. In the formula of plaster of Paris, we have half water molecule. Give reason. Reason is two formula units of calcium sulfate share one molecule of water. So, when you write it for one molecule, one formula unit, it changes to half. Okay. So, with that, this topic is over, and also our second chapter is also over, and I hope it is clear to you.